right. Thank you so much for joining us for this session on how CSPs can manage any application at the edge across a fragmented multi-cloud environment. I'm Kelly Hill, back again to moderate this panel, and really excited for this conversation. I'd like to introduce you to our panelists. Francisco Javier Ramón, who is multi-cloud tools manager in the GCTIO unit of Telefonica and also chair of ETSI's OSM group. And Dario Sabella, who is chairman of the ETSI MEC group. So obviously we've got some folks who really understand the methods behind this madness, and hopefully we'll have a great conversation about how this is happening and some of the complexities involved. So if you have questions, please get them in front of these two folks while you have the opportunity. Submit those through the user interface, and we will get to as many of them as we can. And with that, let's go ahead and get the conversation started. So I wanted to sort of set some context, and as we start this conversation, looked through the RCR archives. The first published reference I could find to mobile edge computing was actually back in 2015. But if I look at the headlines now, 10 years later, I see Verizon's CEO on stage at a JP Morgan conference saying that they were very early on mobile edge compute, maybe too early, but also saying now we're sitting in a really good position on monetizing that investment. So my first question to you gentlemen is, what are the fundamental things that the industry has gotten right, or I'm sorry, has gotten wrong on MEC, and also the things that it's gotten right? And what do you see happening in terms of making sure the next 10 years aren't like the last 10?
Maybe I can
Go ahead, please.
take this one.
Yeah,
Because,
no.
I mean, I would not have a pessimistic view on that. I think that there are multiple definitions of edge that are implicit. And the view that we have 10 years ago probably was much less ambitious than the one that we have now. Well, I'm meaning this because in the end, by edge, we are meaning some degree of decentralization in opposition to what are the traditional clouds, right? And however, that decentralization, it doesn't say much about the actual footprint of that, because it's not the same decentralizing to the point of presence, that decentralizing to a central office, that decentralizing to a cabinet, that decentralizing to the home, or as we've seen this morning, even to the terminals, it's totally different. And actually, the challenge is totally different, because we are talking for each of those layers that I've enumerated quickly. In the end, we are talking about an order of magnitude of growth in the number of locations, in an order of magnitude of cost of operating the thing, etc., etc. So, I mean, justifying, depending on which level you have settled in the past, your experience may vary. So, because also depends on the motivation as well. Why did you centralize to start with? Did you do it because you were deploying some services that was worth that decentralization effort and extra cost, or just because you were expecting some incomes that did not arrive? So I think that hopefully during the conversation we will be able to understand where we are sitting and what are the different cases, so we can define in each of them what success means, because it's a bit tricky. We are using the same word for things that are totally different in their own nature, and probably saying that we have not achieved the whole of them probably was over ambitious by the beginning, right?
Okay, so a more realistic view, it sounds like the industry has taken, but also things have changed over time as well. Dario, what is your perspective on what the industry has gotten wrong and right about MEC in the last 10 years?
Oh, well, thank you for the question. This is actually something that you are asking to a guy which is working on edge computing since the beginning. I was involved there back since the creation, I will say, in 2015 of the MEC group. I have seen this group growing a lot, but really the point was it was conceived as a technology that can be independent from a generation of a mobile telecommunication network, right? So, and there was somebody trying to push it earlier, as much as possible to monetize. Actually, the industry was actually not ready to that and was waiting for 5G and for virtualization. Okay, that was a physiological delay. But then what happened? I've seen many startups failing, also starting from a sort of spin-off from big giants, burning a lot of money because they went to the market too early. And also operators trying to enter to this market, but really in the meantime having a lot of investments for 5G. And this was coming together with the disappointment, general disappointment, I can tell just in general, right? From operators about the real return of investment from 5G itself. So the problem is the money. So yes, Mac can be a tool for monetization because edge computing is supporting a lot of new use cases. But for the basic ones, we still maybe need to see a maturity of 5G. That's why now the 5G deployment is also moving to standalone, and there are more advanced deployments. We are moving to release 17, which is more mature support for edge computing. This is now starting to become the interesting part of the journey. And I believe only the patient guys will survive. A friend of mine corrected me, yes, the patient guy, but with money. Because since a lot of years we are waiting and waiting, of course, some pressure, of course, to introduce those kind of services, but we have also to do a sort of reality check. Ready than you can expect of your wishes, right? So, but we are here, and also from my side, I was driving the standardization, which is actually just a part of the industry, right? We don't need to standardize everything. I will tell you more, but of course, is in support of the ecosystem. I believe now really we are starting the most interesting part of the journey.
Okay, so timing and money, but it sounds like we're there. Hopefully. Okay, so let me follow up on that, and ask Francisco. If you look at the MEC opportunity from the point of view of a carrier, it seems like the idea is to create a flexible platform. And I think we hear a lot of conversations about this, that's capable of supporting, whatever kind of connectivity or compute enabled service that an end user could want, regardless of vertical. So how do you effectively and at scale, build that kind of horizontal distributed platform that needs to serve as kind of a catch-all for an open-ended number of use cases. So let's talk a little bit about architecting that and building that.
Well, I think that the key part is building a real horizontal platform, but while at the same time we need to coexist with a reality of having some sort of fragmentation. If you're decentralizing, somehow you're decentralizing. And to some extent, if you have a healthy ecosystem, it is likely that you are mixing different virtualization technologies and cloud technologies. Okay, so that means some complexity, but the challenge here is being ready to support that large number of sites and virtualization technologies without recreating totally different procedures, right? And that is where the methodologies for multi-cloud come, and actually where we I think that there are a few keys here. I'm not saying that we have the ultimate solution for any kind of decentralization, of course. I mean, but there are some keys here that I would like to mention. Of course, I mean, if you are building your procedures in a cloud agnostic way, that means modeling, means taking into account some well-known paradigms in industry that are independent from one technology to another. We are well positioned. I think that there is I think that there is some sort of a convergence into not only in the applications, but also having some way of declaring what you are doing instead of creating a complex choreography of things that need to happen in a very structured sequence of steps. I think we are moving away from that. Instead, we're moving to more a declarative pattern. That means that you just define the desired state and you forget about it. You don't do any complex choreography, and also going to structures that are naturally resilient. So you don't need to keep an eye on every single aspect of that complex structure, but that you are building on parameters like the GitOps, etc., that provide a continuous reconciliation. So somehow you have a natural protection to any disaster. I think that helps you to somehow to manage that complexity without taking care like the pets and cattle, you know, that paradigm. You move away from the pets and have more cattle in spite that the cows have a different color, you know. So so that is more or less what is the challenge in my view.
Okay. Dario, what's your perspective on sort of, so we talked about some of the architectural concepts of, you know, and some of the requirements of, you know, visibility and flexibility. Any thought, any way that you would expand on that?
Sure. Let's say I can just talk about my perspective on the standardization for the architectural part, right? So actually, we started very early to define what can be the way the technology should evolve by following the market needs. I mean, with that of course, the standard is contribution driven. So actually, companies are willing to produce some interoperable architecture framework, wanted to work on that. And we shaped that to be fully honest, to be access agnostic. Okay, maybe, of course, in this forum, we are, of course, let's say, following the mainstream and talking about what is also driving all the innovation, which is also 5G network. But let's not forget that also edge computing meant standard as well in ETSI was considered to be agnostic. So can be applicable for also not just only mobile network, but also fixed network, Wi-Fi, other kind of accesses. So that is a very transversal concept that can open up the market. Here's an opportunity for operators to collaborate with other domains. So that was the difficult exercise, I would say. I'm very proud of all the delegates that worked with me in all these years, building all the platform as a service, infrastructure as a service, all the APIs, portfolio. We started to collaborate also with the ecosystem, open source projects, also outside ETSI in Linux Foundation, like Camara, and also new projects in open source, which are also linked to the 3GPP specifications, like OpenCAPI, Teraflow SDN, and other projects. So really, it's a collaborative work. I believe this has to follow the market needs, because for who knows me, I'm not just religious about the standardization. Need to standardize everything. Not because I'm lazy, but because I want to standardize only the minimum possible needed. Because if you standardize too much, you risk to close the market. This is not what we want. Okay. The standard, the architecture, and everything else is just standardized because it's needed by the company and so this is the approach. If I can tell you more, also we are engaging with developers. Why? Because to be honest, and we realized that very soon actually that one of the other, let's say, customers of our standard, if you wish, customer of this technology is a developer community, not just only providers, but we need also to address the needs of developers. Okay, and that's why we are organizing events like hackathons, competition, technical challenges to stimulate software production, and the creation of exemplary use cases that can be credibly inspire other developers. We need this kind of software ecosystem. That's why we collaborate with open source, but also we organize hackathons. not just because we love parties, but this is really also another part of the ecosystem. We need just to break what I call it the chicken egg problem. The chicken egg problem is so known is that yes, I have a nice infrastructure at the edge. And I ask to the developers, please develop new applications. If there are no architecture and point of presence, the developer will tell you, sorry, I don't have an infrastructure. Then if you go to the operator, yes, I could deploy new Mac servers. This is costing me money, but I don't have the applications, right? And then you have to knock at the door back to the developer. So actually, the breaking the chicken egg, it's the key. We have to address all the needs from who is providing the infrastructure and who is giving innovation through new use cases and applications. And we are there to serve the ecosystem.
Okay, great. So I want to throw another wrinkle in here, because I think one of the most interesting things that's happening as people sort of really think about edge is that we also have this emergence of AI, and the role of who is going to play what and how is all of that going to work at the edge. So you both kind of given us signals that there's quite a bit to come just at edge in general, but we haven't really talked about what potentially AI plays there. And I think there's a lot of interest in, what's going to happen to network architectures in terms of where compute needs to be. I think there's also interest in, what role will AI play across that sort of distributed infrastructure, and what MEC, if maybe the real value of MEC, ultimately ends up being in supporting AI, is it supporting network functions? Some of that still has to sort of play out in terms of, is MEC about network efficiencies or is MEC about new services? So Francisco, I'm wondering if I can come back to you and say, what do you see happening in terms of AI development and sort of that relationship between AI and MEC?
Well, I think that we can see it from both directions. Is whether, I mean, what would be the added value of deploying AI-related use cases near the edge? There I'm not totally clear on the benefits, because I mean, unless that we are talking about the real far edge, I mean, we're talking about even the running some AI workloads in the on terminal, which is clear the value because it is present now. But then you see that in that spectrum, you jump over to a centralized API for LLM, and then you deploy some workloads that communicate with that centralized API. So far, we are seeing these use cases. Probably there are theoretically it's possible that others could be running more decentralized, but you need, again, they are more expensive. So you need to see the value of the centralized that workload. That is particularly tricky because it's very very expensive, the type of hardware that is involved. But on the other direction, not saying that it's not possible, but it's still a bit unclear. In the other direction, I see a lot of potential because it can help you to manage that complex scenario. I mean, the decentralized scenario, one of the biggest complexities is understanding how to react when anything does not go as expected, and even anticipating any potential trouble that is hidden in your eyes. And that is where AI is particularly good at, because it can detect patterns that can anticipate a problem and even being proactive in fixing, right? So in combined with the other techniques of reconciliation, etc., we are already seeing very, very good results. So the point is that the more complex is the infrastructure that we are running, and more diverse the infrastructure that you are running, the more potential of efficiencies has the AI applied to it. So I think that we are in the early stages, but the potential is really clear from my point of view.
Okay. Great. Yeah, I'm interested to see what plays out in terms of power needs at the edge and some of the physical infrastructure, and the additional cost. If you're putting GPUs at the edge, that's a very different cost and power equation than sort of maybe a more typical cloud infrastructure sort of deployment. Dario, what are your thoughts on where we're going with AI and MEC?
That's a great question. Actually, when we talk about AI, we have to distinguish because, of course, AI can be, maybe most of us is implicitly meaning generative AI, okay? Instead, of course, we know that AI is, I say to my friend, AI is a new technology old of 50 years, right? When I was young, I was playing with neural networks in MATLAB. Very decades ago. So actually, AI can be used, machine learning, for classification, for prediction, and now only recently we see generative AI. So I assume you will imply the later, the last one, but of course, in the other two forms, AI can be everywhere. Can help automation of the networks, operation, saving energy and cost, and many other things. And also prediction is actually part of some APIs that we have published in MEC for the V2X to predict some sort of future quality of service in the journey for the vehicle, a V2X API. But answer to your question, since I feel that you imply generative AI, this is the big elephant in the room, okay? Big also in the sense that you are right, it's consuming a lot. There are large language model, maybe sometimes a fat language model, because they are actually very much expensive. So yes, we can do more. Yes, we are at the beginning of the journey, and I see starting to appear small language models, tiny implementations that can be achievable, more affordable for even smaller companies and in different footprints. Another concern is also the data governance. If I instead take care of where is data coming, if, for example, I consider a private MEC, a private edge, and local AI agents where I can take care of the privacy and security of all the stuff, where data is used, where it's coming from, for the training, for the inference. So there is a lot of potential to the edge. I cannot mention products, but I see since the beginning of the year, there was a conference in January, flagship conference where there was some companies showing to the market, starting to appear some products that can allow smaller footprint implementation on premises or also at the edge of private AI. Okay, so I also think that is the era where we can think about talk about confidential AI. There's also combining together smaller footprint, less power consumption, more achievable and affordable implementation and deployments, also coupling with the possibility to comply with the regulation like EU legislation, and also we may have, for example, European AI Act, also other regulations in terms of preserving the data governance. This is also another important point that is also opening up a possibility for this kind of support of the MEC for the AI. Of course, depends on companies. I can just tell you this is my view, but just interpreting what's happening in the market in this last month, I would say.
Okay. Good. Well, good. It sounds like there's potentially some momentum. So I do want to try and get to one other question just real quick. We've only got a couple of minutes, but I thought there was a really interesting audience question about, what do you think should be the differentiator for CSPs when offering edge services? Because the hyperscalers obviously are in this market as well. In many cases, the CSPs are partnering with hyperscalers on edge compute. And obviously the hyperscalers already have, their model, and so far it has been a very, very good one when it comes to compute. Any thoughts on MEC as a differentiator for CSPs potentially? Francisco, let's jump to you.
Yeah, well, the thing is that, that comes from an assumption why we are decentralizing. There is a narrative around the latency about that. For many use cases, latency is right good at the regional level. So this clause is formally correct from the perspective of assuming that latency is the only thing that matters for this consideration. However, I mean, there are other cases that justify this, particularly because a network needs to have a shape, and a shape requires different locations, right? Because otherwise you can't do this. So it depends on what you are trying to deploy. If you need to serve to the local access network, it's almost impossible to do it from a remote location, just for by definition. So I mean, it depends on the case. Yeah, we need to be more specific on what we are trying to deploy and justify why we are decentralizing. Not necessarily for latency. There are cases where latency is of utmost criticity, but there are not so many, and probably we are not explaining too much the other benefits that have that decentralization. Yeah.
Okay. Real quick, Dario, any thoughts on MEC as a differentiator for CSPs?
Yeah, very quickly, I believe the key is focusing on customers, if I can give them a friendly suggestion, and laser focus on the different vertical market segments. Because I see that for 5G especially is very much valuable that you focus on different markets and then tailor the solution to the needs. We have started a journey in MEC to hear the customer needs. What is their pain point? What they need? Why they need edge? And maybe sometimes the answer, I don't need that always in all my use cases. We have to do a reality check. My suggestion is really to focus on vertical markets and open a door and a discussion to hear their problems and tailor a solution for the edge. The edge is so widely applicable to many use cases, and not a single solution can be for everybody, for all the seasons, okay? So it's not really the case. So this is my suggestion in few words.
Okay, wonderful. Thank you both so much. Folks, go ahead and join us for the next session.